Expression language. This chapter introduces the expression language, also referred to as the EL, which provides an important mechanism for enabling the presentation layer web pages to communicate with the application logic backing beans. The EL is used by both Java Server Faces technology and Java Server Pages JSP technology. The EL represents a union of the expression languages offered by Java Server Faces technology and JSP technology. The following topics are addressed here. Overview of the EL immediate and deferred evaluation syntax value and method expressions defining a tag attribute type literal expressions operators reserved words examples of EL expressions overview of the EL. The EL allows page authors to use simple expressions to dynamically access data from Java Beans components. For example, the test attribute of the following conditional tag is supplied with an EL expression that compares 0 with the number of items in the session scope to be named cart. C. If test equal $session scope cart number of items 0. C. If Java Server Faces technology uses the EL for the following functions: deferred and immediate evaluation of expressions, the ability to set as well as get data, the ability to invoke methods. C. Using the EL to reference backing beans for more information on how to use the EL in Java Server Faces applications. To summarize, the EL provides a way to use simple expressions to perform the following tasks: dynamically read application data stored in Java Beans components, various data structures, and implicit objects, dynamically write data, such as user input, into forms. To Java Beans components, invoke arbitrary static and public methods, dynamically perform arithmetic operations. The EL is also used to specify the following kinds of expressions that a custom tag attribute will accept: immediate evaluation expressions or deferred evaluation expressions. An immediate evaluation expression is evaluated at once by the underlying technology, such as Java Server Faces. A deferred evaluation expression can be evaluated later by the underlying technology using the EL. Value expression or method expression. A value expression references data, whereas a method expression invokes a method. RVALUE expression or LVALUE expression. An RVALUE expression can only read a value, whereas an LVALUE expression can both read and write that value to an external object. Finally, the EL provides a pluggable API for resolving expressions, so custom resolvers that can handle expressions not already supported by the EL can be implemented. Immediate and deferred evaluation syntax. The EL supports both immediate and deferred evaluation of expressions. Immediate evaluation means that the expression is evaluated and the result returned as soon as the page is first rendered. Deferred evaluation means that the technology using the expression language can use its own machinery to evaluate the expression sometime later during the page's life cycle, whenever it is appropriate to do so. Those expressions that are evaluated immediately use the $ syntax. Expressions whose evaluation is deferred use this syntax. Because of its multi-phase life cycle, Java Server Faces technology uses mostly deferred evaluation expressions. During the life cycle, component events are handled, data is validated, and other tasks are performed in a particular order. Therefore, a Java Server Faces implementation must defer evaluation of expressions until the appropriate point in the life cycle. Other technologies using the EL might have different reasons for using deferred expressions. Immediate evaluation. All expressions using the $ syntax are evaluated immediately. These expressions can be used only within template text or as the value of a tag attribute that can accept runtime expressions. The following example shows a tag whose value attribute references an immediate evaluation expression that gets the total price from the session scope to be named cart. FMT. Format number value equal $session scope cart total. The Java Server Faces implementation evaluates the expression $session scope cart total, converts it, and passes the returned value to the tag handler. Immediate evaluation expressions are always read-only value expressions. The preceding example expression cannot set the total price, but instead can only get the total price from the cart bean. Deferred evaluation. Deferred evaluation expressions take the form EXPR and can be evaluated at other phases of a page life cycle as defined by whatever technology is using the expression. In the case of Java Server Faces technology, its controller can evaluate the expression at different phases of the life cycle, depending on how the expression is being used in the page. The following example shows the Java Server Faces input text tag, which represents a text field component into which a user enters a value. The input text tag's value attribute references a deferred evaluation expression that points to the name property of the customer being H. Input text int equal name value equal customer name. For an initial request of the page containing this tag, the Java Server Faces implementation evaluates the customer name expression during the render response phase of the life cycle. During this phase, the expression merely accesses the value of name from the customer being, as is done in immediate evaluation. For a post-back request, the Java Server Faces implementation evaluates the expression at different phases of the life cycle, during which the value is retrieved from the request, validated, and propagated to the customer being. As shown in this example, deferred evaluation expressions can be value expressions that can be used to both read and write data method expressions. Value expressions, both immediate and deferred and method expressions, are explained in the next section, value and method expressions. The EL defines two kinds of expressions: value expressions and method expressions. Value expressions can either yield a value or set a value. Method expressions reference methods that can be invoked and can return a value. Value expressions can be further categorized into RVALUE and LVALUE expressions. RVALUE expressions can read data but cannot write it. LVALUE expressions can both read and write data. All expressions that are evaluated immediately use the $delimiters and are always RVALUE expressions. Expressions whose evaluation can be deferred use the delimiters and can act as both RVALUE and LVALUE expressions. Consider the following two value expressions: $customer, name customer. Name the former uses immediate evaluation syntax, whereas the latter uses deferred evaluation syntax. The first expression accesses the name property, gets its value, adds the value to the response, and gets rendered on the page. The same can happen with the second expression. However, the tag handler can defer the evaluation of this expression to a later time in the page life cycle, if the technology using this tag allows. In the case of Java Server Faces technology, the latter tag's expression is evaluated immediately during an initial request for the page. In this case, this expression acts as an RVALUE expression. During a post-back request, this expression can be used to set the value of the name property with user input. In this case, the expression acts as an LVALUE expression. Referencing objects using value expressions. Both RVALUE and LVALUE expressions can refer to the following objects and their properties or attributes: Java Beans Components Collections Java SE enumerated types implicit objects. To refer to these objects, you write an expression using a variable that is the name of the object. The following expression references a backing bean, a Java Beans component called customer, $customer. The web container evaluates the variable that appears in an expression by looking up its value according to the behavior of page context. Find attribute string, where the string argument is the name of the variable. For example, when evaluating the expression $customer, the container will look for customer in the page, request, session, and application scopes and will return its value. If customer is not found, a null value is returned. You can use a custom EL resolver to alter the way variables are resolved. For instance, you can provide an EL resolver that intercepts objects with the name customer, so that $customer returns a value in the EL resolver instead. To reference an enum constant with an expression, use a string literal. For example, consider this enum class. Public enum suit hearts, spades, diamonds, clubs. To refer to the suit constant suit hearts with an expression, use the string literal hearts. Depending on the context, the string literal is converted to the enum constant automatically. For example, in the following expression in which my suit is an instance of suit, hearts is first converted to suit. Hearts before it is compared to the instance, $my suit hearts, referring to object properties using value expressions. To refer to properties of a bean or an enum instance, items of a collection, or attributes of an implicit object, you use the or notation. To reference the name property of the customer bean, use either the expression $customer name or the expression $customer name. The part inside the brackets is a string literal that is the name of the property to reference. You can use double or single quotes for the string literal. You can also combine the and notations, as shown here. $customer address street. Properties of an enum constant can also be referenced in this way. However, as with Java Beans component properties, the properties of an enum class must follow Java Beans component conventions. This means that a property must at least have an accessor method called getProperty, where property is the name of the property that can be referenced by an expression. For example, consider an enum class that encapsulates the names of the planets of our galaxy and includes a method to get the mass of a planet. You can use the following expression to reference the method getMass of the enum class planet, $myPlanet. Mass. If you are accessing an item in an array or list, you must use either a literal value that can be converted to int or the notation with an int and without quotes. The following examples could resolve to the same item in a list or array, assuming that socks can be converted to int, $customer. Orders $1 customer. Orders. Socks. In contrast, an item in a map can be accessed using a string literal key. No coercion is required. $customer. Order socks. An RVALUE expression also refers directly to values that are not objects, such as the result of arithmetic operations and literal values, as shown by these examples. $literal $customer. Age plus $20 true $57. The EL defines the following literals: boolean, true and false integer, as in Java floating point, as in Java string, with single and double quotes, is escaped as, and is escaped as, no. You can also write expressions that perform operations on an enum constant. For example, consider the following enum class. Public enum suit club, diamond, heart, spade. After declaring an enum constant called mySuit, you can write the following expression to test whether mySuit is spade. $mySuit spade. When it resolves this expression, the EL resolving mechanism will invoke the value of method of the enum class with the suit class and the spade type, as shown here. mySuit. Value of suit. Class, spade. Where value expressions can be used. Value expressions using the $delimiters can be used in static text, any standard or custom tag attribute that can accept an expression. The value of an expression in static text is computed and inserted into the current output. Here is an example of an expression embedded in static text. Sum. Tag. SumText $expr SumText. Sum. Tag. If the static text appears in a tag body, note that an expression will not be evaluated if the body is declared to be tag dependent. LVALUE expressions can be used only in tag attributes that can accept LVALUE expressions. A tag attribute value using either an RVALUE or LVALUE expression can be set in the following ways. With a single expression construct, sum. Tag value equal $expr. Another. Tag value equal expr. These expressions are evaluated, and the result is converted to the attribute's expected type, with one or more expressions separated or surrounded by text. Sum. Tag value equals some $expr text $expr. Another. Tag value equals some expr text expr. These kinds of expression, called composite expressions, are evaluated from left to right. Each expression embedded in the composite expression is converted to a string and then concatenated with any intervening text. The resulting string is then converted to the attribute's expected type. With text only. Sum. Tag value equals sumText. This expression is called a literal expression. In this case, the attribute's string value is converted to the attribute's expected type. Literal value expressions have special syntax rules. See literal expressions for more information. When a tag attribute has an enum type, the expression that the attribute chooses must be a literal expression. For example, the tag attribute can use the expression hearts to mean suit. Hearts, the literal is converted to suit, and the attribute gets the value suit. Hearts. All expressions used to set attribute values are evaluated in the context of an expected type. If the result of the expression evaluation does not match the expected type exactly, a type conversion will be performed. For example, the expression $1.2e4 provided as the value of an attribute of type float will result in the following conversion. Float. Value of 1. 2e4. Float value. See section 1.18 of the Java server pages 2. To expression language specification available from http://jcp.org. About Java. Community process. Final. JSR 245. For the complete type conversion rules, method expressions. Another feature of the EL is its support of deferred method expressions. A method expression is used to invoke an arbitrary public method of a bean, which can return a result. In Java Server Faces technology, a component tag represents a component on a page. The component tag uses method expressions to invoke methods that perform some processing for the component. These methods are necessary for handling events that the components generate and for validating component data, as shown in this example. H. Form, H. Input text int equal name value equal customer. Name validator equal customer. Validate name. H. Command button int equal submit action equal customer. Submit. H. Form. The input text tag displays as a text field. The validator attribute of this input text tag references a method called validateName in the bean called customer. Because a method can be invoked during different phases of the life cycle, method expressions must always use the deferred evaluation syntax. Like LVALUE expressions, method expressions can use the and the operators. For example, object method is equivalent to object method. The literal inside the is converted to string and is used to find the name of the method that matches it. Once the method is found, it is invoked, or information about the method is returned. Method expressions can be used only in tag attributes and only in the following ways. With a single expression construct, where bean refers to a Java Beans component and method refers to a method of the Java Beans component. Sum. Tag value equal bean. Method. The expression is evaluated to a method expression, which is passed to the tag handler. The method represented by the method expression can then be invoked later. With text only. Sum. Tag value equals sumText. Method expressions support literals primarily to support action attributes in Java Server Faces technology. When the method referenced by this method expression is invoked, the method returns the string literal, which is then converted to the expected return type, as defined in the tag's tag library descriptor. Parameterized method calls. The EL offers support for parameterized method calls. Method calls can use parameters without having to use static EL functions. Both the and operators can be used for invoking method calls with parameters, as shown in the following expression syntax. EXPRA EXPRB parameters EXPRA. Identifier B parameters. In the first expression syntax, EXPRA is evaluated to represent a bean object. The expression EXPRB is evaluated and cast to a string that represents a method in the bean represented by EXPRA. In the second expression syntax, expra is evaluated to represent a bean object, and identifier b is a string that represents a method in the bean object. The parameters in parentheses are the arguments for the method invocation. Parameters can be 0 or more values or expressions, separated by commas. Parameters are supported for both value expressions and method expressions. In the following example, which is a modified tag from the guessNumber application, a random number is provided as an argument rather than from user input to the method call. Input text value equal user number bean. User number 5. The preceding example uses a value expression. Consider the following example of a Java server faces component tag that uses a method expression. Command button action equal trader. By value equal by. The EL expression trader. By calls the trader beans by method. You can modify the tag to pass on a parameter. Here is the revised tag where a parameter is passed. Command button action equal trader. By stock value equal by. In the preceding example, you are passing the string stock a stock symbol as a parameter to the by method. For more information on the updated EL, see http://l Java.net. Defining a tag attribute type. As explained in the previous section, all kinds of expressions can be used in tag attributes. Which kind of expression and how it is evaluated, whether immediately or deferred, are determined by the type attribute of the tag's definition in the page description language poundle that defines the tag. If you plan to create custom tags for each tag in the poundle, you need to specify what kind of expression to accept. Table 6-1 shows the kinds of tag attributes that accept EL expressions, gives examples of expressions they accept, and provides the type definitions of the attributes that must be added to the poundle. You cannot use syntax for a dynamic attribute, meaning an attribute that accepts dynamically calculated values at runtime. Similarly, you also cannot use the $ syntax for a deferred attribute. Table 6-1 definitions of tag attributes that accept EL expressions. Attribute type example expression type attribute definition dynamic literal. Retext per value, true. Retext per value, $literal. Retext per value, true. Retext per value, deferred value literal. Deferred value, type, Java. Lang. String. Type, deferred value. Customer. Age. Deferred value, type. Int. Type, deferred value, deferred method literal. Deferred method, method signature, Java. Lang. String submit. Method signature, deferred method, customer, CALC total. Deferred method, method signature, double CALC total int, double. Method signature, deferred method. In addition to the tag attribute types shown in Table 6-1, you can define an attribute to accept both dynamic and deferred expressions. In this case, the tag attribute definition contains both an retext per value definition set to true and either a deferred value or deferred method definition. Literal expressions. A literal expression is evaluated to the text of the expression, which is of type string. A literal expression does not use the $ or delimiters. If you have a literal expression that includes the reserved $ or syntax, you need to escape these characters as follows, by creating a composite expression as shown here. $expra exprb. The resulting values would then be the strings $expra and exprb. By using the escape characters $and to escape what would otherwise be treated as an eval expression. $expra. EXPRB. The resulting values would again be the strings $expra and exprb. When a literal expression is evaluated, it can be converted to another type. Table 6-2 shows examples of various literal expressions and their expected types and resulting values. Table 6-2 Literal expressions. Expression expected type result high string high true boolean true 42 and 42. Literal expressions can be evaluated immediately or deferred and can be either value or method expressions. At what point a literal expression is evaluated depends on where it is being used. If the tag attribute that uses the literal expression is defined to accept a deferred value expression, when referencing a value, the literal expression is evaluated at a point in the life cycle that is determined by other factors, such as where the expression is being used and to what it is referring. In the case of a method expression, the method that is referenced is invoked and returns the specified string literal. For example, the command button tag of the guest number application uses a literal method expression as a logical outcome to tell the Java server faces navigation system which page to display next. Operators. In addition to the and operators discussed in value and method expressions, the EL provides the following operators, which can be used in RVALUE expressions only: arithmetic, plus, dash binary, and div. And mod, dash unary logical, and, or, not, relational, ec, equal, ni, lt, gt, equal, ge, equal, le. Comparisons can be made against other values or against boolean, string, integer, or floating point literals. Empty. The empty operator is a prefix operation that can be used to determine whether a value is null or empty. Conditional. A, B, C. Evaluate B or C, depending on the result of the evaluation of A. The precedence of operators highest to lowest, left to right is as follows. Used to change the precedence of operators unary not. Empty. Div. Mod plus binary. Equal. Equal LTGT LGE. Equal ECNI and OR. Reserved words. The following words are reserved for the EL and should not be used as identifiers. And or not ECNI LTGT LGE true false null instancy of empty div mod. Examples of EL expressions. Table 6-3 contains example EL expressions and the result of evaluating them. Table 6-3 example expressions. EL expression result $1. 4. 2 false $4. 0. Equal 3 true $100. 0 100 true $10 10 me 100 false $A. B true $hip GT hit false $4. 3 true $1. 2 E4 plus 1. 4 12,001. 4 $3 div 40. 75 $10 mod for $2. Empty param. Add false if the request parameter named add is null or an empty string. $page context. Request. Context path. The context path. $session scope. Cart. Number of items. The value of the number of items. Property of the session scoped attribute named cart. $param midcom. Product id. The value of the request parameter named midcom. Producted. $header host to host. $department's depth name. The value of the entry name depth name in the department's map. $request scope javax. Servlet. Forward. Servlet path. The value of the request scoped attribute named javax. Servlet. Forward. Servlet path. Customer. Lname gets the value of the property Lname from the customer being during an initial request, sets the value of Lname during the postback. Customer. CALC total. The return value of the method CALC total of the customer bean.